Okay. Thank you very much for that kind introduction and for the invitation. As Tia just said, the title here is AI and Cognitive Science Need a Divorce, and I'll get back at the very end to what exactly I mean by that. But what I'll be talking about is cognition, computation, and common sense. And yeah, I should maybe say at the beginning, my task just now got both much easier and much more difficult, because my presentation actually overlaps quite much with the previous two presentations. So that makes it easier because I don't have to go through all my slides and run out of time, but it also makes it a bit harder because it's much more difficult to say something new now. Okay, I'll just get started. Okay, this is just a quick illustration of my background. What I'm currently working on in the last 5 or 10 years is how people interact with technologies like this. So what I'm nowadays most interested in is how people interpret this type of technology. But as Tia just said, I come from a computer science background, and I did lots of research on neural networks and much more applied research, for example, neural networks for radar image interpretation and so on. So I've come from a computer science background and come to cognitive science from that. Okay, but yeah, I'll not talk so much about our specific research, but what I am talking about is I've tried to structure it into 5 sections here, or 5 points. The first thing overlaps very much with something that you've already heard a couple of times now, namely the fact that people are confused about the relation between AI and human cognition. And I want to dig a little deeper there and ask, but what exactly are they confused about and why? Then I'll talk a bit about cognition and computation. That's also been talked about a little bit. I'll talk about common sense and why that still is a problem for AI. I'll talk about anthropomorphism, but not super much, because that's also already been addressed in Arnold's talk. And at the end, my conclusion. So if after reading this you can fall asleep, because that's the conclusion that I'll have at the end, the last point will be that a more realistic view of the relationship between AI and human cognition is that they're fundamentally different, which again you've heard before, and that they should be viewed as complementary rather than one replacing the other. Okay, so let's go through these points here. The first point, I think one slide disappeared here, but the first point here was that people are confused. And I think many people can agree about that, but the question is, of course, what are they confused about and why? Here's, for example, an article from the New Yorker from last year by Jaron Lanier, one of the inventors of virtual reality. And he's even arguing that there is no such thing as AI. It's just a big myth. So that's one argument. Then here's another illustration that might be a little confusing, that illustrates the confusion, because it illustrates this progress that we've all been experiencing in recent years. And according to this particular diagram, the point that I'm interested in is in the upper right there, and particularly those graphs there for reading comprehension and language understanding. So according to this graph, for example, AI systems had 0 reading comprehension by 2016, and now they are better at reading comprehension than people are. And the same or similar for language understanding. According to this graph, AI systems had 0 language understanding 2018, and by now they are better than people at language understanding. Which of course makes you wonder, what exactly is it that people are measuring here? And what exactly is their notion of understanding? Because I assume all of us, the Mentimeter seems to indicate it, all of us have interacted with ChatGPT, and I think we can all agree that there's some sense of understanding, but certainly other senses of understanding are missing there. So we see a lot of these graphs and we experience and then see lots of progress, but it's a little difficult to say, it's a little confusing to know what exactly is the progress here and what exactly is being measured in progress graphs like this. So yeah, ChatGPT, or in this case it's Bing, so something similar. We've already talked quite a bit about it, and this is just an illustration. This was an article in the New York Times last year, which got quite much attention because it was early in the year, I think February. And in this case, a New York Times reporter talked for 2 hours to a chatbot and really pressured it to talk about difficult issues and so on. And among other things, the chatbot said things like that it wants to be alive and that it's in love with the reporter, and that the reporter doesn't really love his wife and that he should break up with his wife and get together with the chatbot, and also that it said things about hurting people and so on. And the interesting question here is, of course, again, this issue of understanding. On the one hand, it's impressive that you can have that kind of conversation with a chatbot. On the other hand, probably most of us agree. I mean, some people, as Enel had that example in his talk of somebody who actually thinks that systems like these are conscious, but I think most of us would agree that much of this is, of course, nonsense. This chatbot does not want to be alive. This chatbot is not in love with the New York Times reporter, and this chatbot doesn't even know anything about the New York Times reporter's wife and relationship. So it's, of course, all hallucination or confabulation. And that's the reason why this is interesting is, of course, that we can take both of these perspectives. On the one hand, we can treat this agent as if it was a person that we're talking to. And in that case, statements like, I want to be alive, well, in the case of a person, that doesn't make much sense, but a statement like, I love you would be quite an exceptional statement from, let's say, the person sitting to our right or something like that. And so, on the one hand, we can take that perspective. We can interpret this as if it was a person. On the other hand, we can take presumably many people here have a technical background, so we can also take the perspective that, well, this is just a piece of technology, and we understand that it doesn't have any of these desires that it keeps talking about. Okay, so that's part of the confusion, that we always have these dual perspectives. And I threw together a couple of quotes here that I call questionable quotes. And I can tell you the common denominator is that everybody on this slide has won a Nobel Prize and said something stupid about AI at some point or other. Okay, first one, Herbert Simon, 1960. He said, machines will be capable within 20 years of doing any work that a man can do. At that point, people were still using the word man like that, referring to human beings. Okay, we know he wasn't right about that. But this quote illustrates this strange obsession that people had back then. The idea that computers could do everything that people can do. That's an interesting question. Why exactly that's the case? Then there's another. Geoffrey Hinton has already been mentioned today. Also just won a Nobel Prize, and he said something stupid or semi-stupid. 2016, he said, people should stop trading radiologists now. It's just completely obvious that within 5 years, deep learning is going to do better than radiologists. And again, there's this confusion about what AI systems can do. They certainly are very powerful tools in radiology, and they certainly can help people coming to the right diagnosis. But I think most people by now would agree that they certainly can't replace people. So the idea that there's not going to be any radiologists anymore because machines will do it all is somehow mixing up this idea of complementing people or helping people and replacing people. Okay, by the way, he has, of course, he's been asked about this, and then he said later that, okay, I got the time scale wrong. It's not 5 years, it's 10 years or 20 years. So he still believes this, but with a little twist there. And then Daniel Kahneman, who's already mentioned been twice, he said something interesting in an interview with a Swedish newspaper where he was asked about, is there anything unique about human intelligence? And okay, the interesting point here is, of course, that Kahneman is a psychologist. And so he was asked, is there anything unique about human intelligence? And he said, oh, I don't see what is unique about human intelligence. You know, we have a computer in our head, and the idea that that's a completely different kind of computer, it doesn't make sense to me. And I just include this quote here because this illustrates this tendency of not only people coming from a technical background, thinking that computers could be smart or intelligent or conscious, but it's gone so far that even people in psychology talk about brains or computers or people as if, talk about people or brains as if they were computers. So although, many people would disagree with this, and many people like Anil and me keep repeating that brains are not computers, people are not computers, there are people in psychology, in philosophy, and so on. There are lots of people who think that human cognition is in fact computation. Okay, we get to the second point here, cognition and computation. And as I just said, this is an idea that has dominated the cognitive sciences and AI for, by now, at least 60 years. There's, for example, I just threw in a book title here on cognition and computation, which takes exactly that view that human cognition is computation. Also, if you look it up on Wikipedia, I think that quote it says today, but I did it yesterday. It says, their thinking can be best understood in terms of representational structures in the mind and computational procedures that operate on those structures. That comes from a book by Paul Thagard from 2008. But also, I just threw in another recent example here from Nature Neuroscience, published this month, and the very first sentence in the paper says, the brain is thought to rely on persistent internal representations of continuous variables for a wide range of computations, from working memory to navigation to motor control. So this has really become a widespread viewpoint in the cognitive sciences that cognition is some kind of computation. So that's just despite the fact that other people keep pointing out that's of course, it's not correct, or it's at least a problematic assumption. So Anil talked a little bit about Alan Turing and how Alan Turing defined computing and gave a definition of what it means to compute. And one little historical fact that's interesting to add there is that at the time, the word computers actually, of course, referred to people, because computers were that type of people who were doing calculations with pen and paper or with certain machines, and those were the computers. And then Alan Turing came along. Alan Turing had a background in mathematics, and he invented this thing called the Turing machine. And what he tried to argue was that kind of machinery can do all the computations that the computers on the left can do with pen and paper or with those tools that they're using. And this is part of how these ideas of computation and cognition, how those got confused, because what Turing said was, okay, artificial computers of this type can actually do all the computations that human computers can do, but that's of course not the same as saying that anything that goes on in these people's heads can be computed by a computer. Okay, but that's the details here would require a whole history lesson, but this is part of how the confusion came about, because computers were people at the time, and then people came up with an artificial notion of computation, and somehow the two are still connected to each other. So although Turing was 70 years ago now, or even more than that, people still hang on to this idea of cognition being computation. Okay, common sense is the next point on my list here. And common sense, again, is an interesting question or an interesting point, an interesting issue from a historical perspective, because it's always been acknowledged as a problem in AI I think the first paper on common sense that I remember is from 1958, so just like a year or two after AI as a field was invented. And the interesting thing is that many people already pointed out these problems with common sense. Here's a book by Mortimer Tobe and another by Hubert Dreyfus. They pointed out these problems with machines and common sense 60, 50 years ago. And the interesting thing is that most of those problems still exist, although people in AI often try to deny it. Here are just some current examples. Many of these are, of course, taken from the internet, so some of you might already have seen this. This is an example of something that's obvious to us, but wasn't obvious to that particular algorithm or whatever you want to call it, that particular AI system that did this classification. All of us understand that there's no such thing as 5 meters long cow in reality, but yeah, if you're an AI system, how would you know that? Here's another example which just happened, I think just a couple of weeks ago, where you can't see it so clearly, but the first vehicle there in the middle is a trailer truck which is carrying a tree. And the automated vehicle that is following this truck gets very confused by the fact, because it has, of course, been trained that trees are things that are stationary and have to be avoided. So now it keeps seeing this tree and it tries to go left and right, but somehow the tree, of course, never goes away. So it's confused about that. And again, this is just an example of something that is obvious to all of us, but it's not obvious to automated vehicles, or this particular automated vehicle. Okay, and that, of course, is an interesting fact. Although the problem of common sense has been discussed as a problem in AI for at least 66 years, if I calculate right, and people have written dozens of books about this, we still hang on to this idea that machines could have. I mean, the reason that we're surprised and amused by these examples is that it's that they do something wrong that you wouldn't expect them to do wrong, and you kind of ask, okay, but why don't they know this? I'll have a couple more examples later. But this is just an interesting illustration. If we talk about robots for a minute here, this comes from MIT Technology Review in the summer. I think it's the June issue, the cover of the June issue. And so this is now. And the headline there is, "The robots are coming and they're here to help." It's, of course, a very positive picture. And if you have a look at the details here, the robots are, of course, they're exceptionally, they fit into the human context very well. And they although they look different, they look human-like to some degree, but they're not completely human-like in any scary way. But they seem to be extremely well adjusted to the human social context. So, for example, the robot holding the baby clearly seems to have an understanding of the emotional relevance of the baby, and handling it carefully and handing it over carefully. And also the other robot that's playing with the girl there is, in a sense, even more impressive, because look at the construction of what they're building. They have a book, they have some other books on top of the book, and then they're stacking wooden blocks on top of that. So this would really require these robots to have some kind of shared, it would really require these robots to share our view of the world, and some kind of shared commitment to certain things happening in the world and certain things not happening in the world. Which is, by the way, a little different from the cat that you see there in the lower right, because cats are an example of non-human agents which are part of our social world, but they don't share this commitment. So that cat can, for example, any moment now, it could be knocking over the tower that the robot and the girl are building. But this is an interesting illustration of people are still aiming for this view of AI, robots in this particular case, that really share a human perspective of the world, despite the fact that we have evidence that it's really, really, really difficult to build systems that share the human perspective. Here are some more examples. a case where an Uber, an automated vehicle, killed a person in Tempe, Arizona, in 2018. And this particular case, it's an illustration of common sense, because in this particular case, the vehicle couldn't quite decide. It detected something on the road, but it couldn't decide, is this a person, is this a bicycle, is this something else, and kept switching between different classifications until just like a second or so before the collision, it tried to hand over control to the human safety driver sitting in the car, which again is the complete absence of common sense. If you can't decide is this A or is this B, you stop anyway because you understand that colliding with something is not a good idea, independent of what it is. Here's another example. This happened in San Francisco last year, where somehow somebody ended up under a car, and the car, of course, lacked the understanding of the situation that would have allowed it to just stop, and it dragged the person along. And as a result of that, that whole robotaxi trial had to be abandoned at the time. Okay, so what I want to talk a little bit more about is why is there still this problem of common sense? Because clearly these systems are in the same physical environment like us. They share our physical world. So why don't they understand? Why don't they understand the world in the sense that we do? The image here on the upper left is from our campus, where we have a couple of autonomous shuttle buses that move around, and they share the world with pedestrians, as you see there, and bicyclists. The picture on the right there is a similar situation, except that's a normal car there with a human driver. And I'm just using this picture to raise that question. So why does the automated vehicle in the upper left not have the same understanding of the world? It's kind of obvious, isn't it? Because if you look at the picture in the lower right there, it's of course the case that anybody who drives a car, or practically anybody who drives a car, has also been on a bicycle. Practically anybody who rides a bicycle has also been a pedestrian, and so on. So these people there, pedestrians, bicyclists, and car drivers, they've all been in each other's situations. Of course, they're children who haven't been car drivers and so on, but they all have a lot in common. Whereas if you look in the image again from our campus, of course that bus has no understanding of the pedestrian perspective, it has no understanding of the bicyclist perspective, and it will never be in their situation. So that's of course one of the reasons why there is no common sense, in the sense that there's a common, in the sense of a shared understanding of the world, because as Anil also discussed, our understanding of the world comes from our embodied interaction with the world, and systems like that, automated vehicles, of course, have a physical interaction with the world, but they don't have the same embodied interaction. Okay, I want to very quickly talk a little bit about anthropomorphism. This has already been up, and I just want to go through it very quickly here, because all of this, we talk about AI here, but many of these problems have, of course, been around for much longer than that. This is an example of a German house 120 years ago, who was said to be able to calculate. So people could ask it questions, you can see there on the lower left, could ask it questions like 2/3 plus 3/4. And I would bet many of you couldn't even do that in your head, but the horse could do it, or they thought they could do it, so it would tap out the answers with its hoof. And this didn't just happen once or a couple of times. This got a lot of attention. This is some articles from the New York Times at the time. And people even started a scientific commission consisting of professors and whatever. And they came to the conclusion, yes, the horse really does this. And of course, I think you get to the point of the story here. In the end, they found out that the horse, of course, couldn't do the calculations. What they found out was that what the horse really did, but they only realized this like 3 years later or so, was it read the body language of whoever was asking the question. So if the person who was asking the question did not know the answer, then the horse also couldn't answer it. But just reading bodily signals from the person who asked the question, it was able to do it. And there's, of course, an interesting connection here to what I talked about at the beginning about ChatGPT. And this has also been pointed out by Herbert Reutblatt last year. The interesting point here is the public really wanted to believe that this horse was cognitively sophisticated. It's an entertaining idea, just like the idea that you can have a conversation with ChatGPT about whatever, your life and your relationship and so on. So the public really wanted to believe that. And it's, of course, also the case that the horse here was clever. It was doing something really remarkable, and it took people 3 years to figure out what it did, really. But the problem that the whole horse solved was a completely different problem from what people thought that the horse did. And yeah, as Reutblatt points out, it took careful analysis and experimentation to find out what the horse was doing and what it was not doing. And this is, of course, exactly the situation that we find ourselves in with things like ChatGPT now. Of course, ChatGPT is doing something really, really remarkable, but it's not doing language understanding in the sense that we are doing it. That much is obvious. Okay, so the last point here, and it literally only takes a minute, I think. As I said in the beginning already, so a more realistic view of the relationship between AI and human cognition is that they're fundamentally different and should be viewed as complementary. So what I talked about is that for historical reasons, many people in AI and cognitive science believe, and still believe, that cognition is computation, and that therefore, because Turing machines can compute everything that can be computed, that therefore AI is possible. But as I said, and as also Arnold said, there are good reasons to think that those claims are questionable. Then, yeah, Arnold discussed this in more detail. Humans are biological creatures, and the way we perceive the world and interact with it depends on our biological embodiment and our social situatedness. And of course, AI and robots and so on have access to our world to some degree through data or through sensors and so on. But the point here is, of course, they will always have a fundamentally different perspective of things, which, if you think about it in terms of complementarity, is, of course, is great. You don't want AI to be human-like, because if it's human-like, it can't help you very much. Okay, and the last bullet point here, before I'm getting pushed over stage. Okay, but the interesting thing is, of course, that you all can understand this rationally, but in interactions with AI, computers, robots, all of us still tend to attribute human-like cognitive, perceptual, and so on capacities to such technologies. And we just have to be more aware of that. And that's my very last point here. Yeah, people simply need help with expectation management. So I think that's the lesson or the take-home message for anybody building AI systems, selling AI systems, and so on, is that people need help with understanding what they can expect and what they cannot expect from a system like that. Okay, and the last slide is just the questions slide. Okay.
Thank you, Tom.